Okay, so in this teaching worksheet for integration, we are looking at more techniques of integration. So in the first teaching worksheet, you already gotten the three basic integration formula. And also in the first teaching worksheet, you also have the part about finding equation of the curve using the three basic formula. But in the equation of the curve, there is an extra constant that the question will provide you the information to calculate. So it will be the same thing. So later on, there will be a trigo. Like let's say you are given your dy dx in trigo, you will also be expected to find the original equation of the curve, or you will be given dy dx in terms of exponential, and then you will need to integrate to find the original of the curve. So basically, it's almost the same idea as teaching worksheet 1, except that the formulas will be based on trigo, exponential, and log. Okay, so for the trigo integration, there will be these two blocks of basic formula. So for these two blocks of basic formula, the only difference is uh, whether the angle is x or whether the angle is a linear function. So the angle here is x, and then the angle here is a linear function. So it doesn't work for angles that are like other function like quadratic or other things. So very strictly, it is only for these two type of angle. Okay, and where does the formula come from? Actually, the formula comes from differentiation, obviously. So if right now you got the idea of differentiation, so previously we know that differentiate sine x is a cosine x. So when you integrate backwards, you get integrating cosine would be equal to sine. So that's how the formula comes about. Okay, so you can think from the differentiation idea. So for me, I always think about the differentiation idea. Okay, so differentiate cosine, we know there is a minus sign. Okay, that's why if I'm going to integrate back, I integrate my minus sign, I will get back my cosine. So if I would like to isolate just the sine x, the negative one will be divided over. So that's how I get a negative here. Okay, so you think the opposite of your differentiation. You find a way that you remember better. So for me, I remember better through differentiation. So I will link it back. Okay, so in differentiation, if you differentiate tangent x, it gives you a secant square x. So that's why if you integrate back, if you integrate secant square, it gives you back the tangent x. So everything comes from the idea of differentiation, and but you reverse the idea. Okay, so that's how I remember. But over the years, I also have students who tell me they actually remember better through integration formula. It's up to you how your brain process. Okay, and then if you recall, when you try to differentiate sine ax plus b, so do you recall the process? You differentiate the function first, and then you got to differentiate the angle. So when you try to do this, right, you actually multiply by a. And a is your coefficient of x. So right now, because it's the opposite, so if I'm going to integrate a cosine ax plus b. So if I'm going to integrate everything here, I will get back my sine ax plus b. But this a will become a divide. So this a will become a divide. So essentially it's something like sine ax plus b divided by a, correct? So usually we don't write it this way. We will write it as a 1 over a. So it's almost similar as your differentiation. By your differentiation, you multiply by a. So right now you're going to divide by a. So you realize that everything is the same. Integrate sine gave you a cosine, same as this idea. But here is a -1 over a. So integrate cosine, give you a sine, so same thing. In a way, you integrate the function first, then you followed by the 1 over a. So same thing for this, integrate secant square, give you a tangent. So it's the same thing, except that now, instead of multiplying by a, like you did in your differentiation, you are going to divide by a. So that will be the main block of formula that you need to know. So you are very restricted by these two blocks of formula. That's why there will be some different integration of trigo that is harder. Okay, so that's later on I will show you. So right now I'm going to show you the basic first. Okay, so I'm going to show you the basic. So for example here, if I'm going to integrate this, so integrate sine x according to the formula, it's just a minus cosine x. So integrate a constant will give you a 2x. So it just integrate one by one. Okay. And then if you try to integrate this, so if you integrate 1, based on your basic formula, that will be a x. Then when you integrate a cosine, you will get a sine. And just put a plus c. Okay. Now the next one, if I integrate this, integrate secant square, give a direct tangent x. Integrate a sine, give you a minus cosine x. So basically it's about how you remember the formula. So integrate sine, integrate cosine. Okay, so let me show you. So example 1 is more like the one where angle is equal to x. So example 2 will be where your angle is ax plus b. So when the angle is ax plus b, you will need to take note of what is your a first. It will be good that you take note what is your a. Okay, so for example here, I'm going to integrate this. Okay, I notice my a is going to be 4. So for you, maybe you want to write it at the side first. So if I do integrate, integrate cosine will be differentiate sine is cosine. So that means you will get 1 over a, and then you get a sine 4x plus c. Integrate cosine will give you a sine, but you got a 1 over a. So I'm using this one. I'm using this part here, this formula. So integrate cosine is going to be giving you a sine. And then don't forget you got a 1 over a. It will be good if you write the a at the side. Okay, after that, then you try to simplify. And that's it. That's your answer. So in the next one, okay, look for your a first. You realize your a is 1/4. Okay, so if you go for the sine ax plus b formula, there will be a negative 1 over a. So you do have a negative 1 over 1 over 4. So don't try to mental and you try to put it right properly. And then it becomes a cosine 1/4 x plus c. So from here, you can try to work out. Okay, you can try to work out carefully. And then, so that will be your final answer. Okay, then the next one, sometimes some students will get their A wrong. So their A is actually a -1. Okay, so when you integrate, be careful. So notice that the A is a -1. So if I integrate, I will have a 1 over A, and then I gotten a sign. So you need to notice that it's a -1. A is a -1, which some students will miss out. Okay, so integrate cosine. Okay, the next one, right, if you take a look, it looks a little bit complex, but in actual fact, A is equal to 2. So you apply the formula 1 over A, and you get a sine 2x plus pi over 4. Okay, then here, so observe where is your A. Your A is 1. So if you use a formula, it will be -1 over 1. A is a 1, and you got a cosine x minus pi over 4. So it's all about knowing what is your A. Okay, this part, A is 5, quite obvious. So if I got to integrate this, I will get a 1 over 5 tangent 5x. And that will just be a 3 over 5 tangent 5x. Okay, so that should kind of illustrate the 2 blocks of formula. Because you are so restricted by these 2 blocks of formula, you cannot do any integration of product of trigo, fraction of trigo. You realize the formula here doesn't allow you to do, like, let's say sine x over cosine something, or it doesn't allow you to do sine x times cosine x. And we don't have a product rule in our integration. In differentiation, we still have. Okay, so you need to make sure we are very restricted to these 2 blocks of formula where it comes to trigo integration. So whatever is it, we will need to twist back any trigo integration to these 2 blocks. If you are not able to twist any trigo back to these 2 blocks, you actually cannot integrate. Okay, so before we go to further parts, the more difficult part on this, you need to know this basic first. And the formulas will not be provided to you during O levels. So of course, you need to memorize this one.